So hello students, welcome to my class and you are watching my channel A Journey with Physics. Today again I have come with some beautiful problems on electric field and charges related to all medical exams and engineering exams. So before actually starting of the class, I also want to give you some information that in my channel there is playlist on class 12, 11 physics and 12 physics where I have uploaded some videos in Bengali version, but I can assure you I am coming with some class 12 physics classes in English version definitely. So now let's start the class for today. Now first question, here is the first question for you. A thin rod of length L is uniformly charged with charge Q. Find the electric field at a distance x from the nearer end of the rod. In the diagram AB, the length of the rod, which is L, we let, and we are interested to find out the electric field at point P, which is at x distance from the B end, because in this question here it is asked from nearer end to find the electric field. So B is near to that point, so the distance is x from B to P is x. That is, so the distance between A and P is L plus x because the length of the rod is L. Now we take a dr element of that rod from point P, which is at distance r, here it is given. Now the charge of the rod is Q, it is given in this question. So line charge density lambda, that is of Q by L, that is the charge per unit length is Q by L. So charge of dr element, if we say that dq, then dq is given by lambda dr, because lambda is the charge per unit length and the length is dr. So the charge on that dr length is dq, and this dq is given by lambda dr, and we have put the value of lambda Q by L here. So dq is Q by L into dr. Now electric field at point P due to this dr, you can see the diagram also. Now for this dr at point P, if we want to find the electric field which is at a distance of r, then according to the definition of the electric field, we know the 1 by 4 pi epsilon naught dq by r square, and this dE, because the small value of electric field, because the distance that is the dr, we choose dr is very small. So due to this dr, the field will be at point P will also be very small. So we have written dE 1 by 4 pi epsilon naught dq by r square. So total field due to this whole rod is the integration process, because if we choose an infinite number dr on that rod, and for each dr we can find electric field at point P, and if we add all the electric fields at point P, then we can have the total electric field due to this whole rod. So that process is governed by the integration process. So now the integration is dE, put the value of dE, and the integration limit is x to L plus x, because of from point P the distance of B is x, and from point P the distance of A is L plus x. So if you can do L plus x minus x, then you can find the length of L. That means you can find the effect of total length L, which is the rod, and you can find the total electric field for that rod at that point P. So limit will be from x to L plus of x. So 1 by 4 pi epsilon naught is coming outside the integral sign, and q by, we have also put here the value of lambda that is of q by L, and integration of 1 by r square, you know that integration is 1 by r and the limit is x to L plus x. And if you know the integration processes, then the reverse of this limit will absorb this minus sign. So here the lower limit is written here first and then minus sign and 1 by L plus x, because this minus sign reverses the integral limit. Okay, so then doing this LCM, and we have the ultimate result, that is of 1 by 4 pi epsilon naught q by x into L plus x. This is the ultimate result or ultimate answer of this electric field, due to this rod at point P. Okay, now if you are asked to find out the electric field in CGS processor, then you replace 1 by 4 pi epsilon by 1, that is of, you just replace this 1 by 4 pi epsilon and you have the result q by x into L plus x. This is in CGS processors result. So you can see the processes are done. Now moving to the next problem. In a parallel RC circuit, the current is governed by I equals to I naught e to the power minus lambda t, and now find the charge over the entire pulse period. Let me explain that. We know I equals to dq by dt. Then dq can be written as I dt. So total charge, integration of dq, integration limit, here we put 0 to infinity I dt. Now why this integral limit is 0 to infinity? Let me explain you. Because here it is given in this question, find the charge over the entire pulse period. Now what do you mean by the entire, over the entire pulse period? If you see the relation of this current, I equals to I0 e to I naught e to the power minus lambda t. If you can see the relation I summan I naught e to the power minus lambda t, then if we put the value of t infinity, then e to the power minus infinity is 0. That means current is 0. That means after time t infinity time, after time infinity, then current can be 0. So how long current is there, the charges are also flowing through this circuit. That means after time t equals to infinity, the charges will have the maximum value. That means over the entire pulse period is meant from 0 to time interval to infinity. That is, when time t is infinite, the current is 0, and when current is 0, the charge also is 0. So to find the total charge, we have to put the total limit from 0 to infinity, from lower limit to upper limit, that is of 0 to infinity. So we put here from lower limit 0 to infinity I dt, and we put the value of I, that is the current equation, I0, I naught e to the power minus lambda t, and I naught is coming outside the integral, and e to the power minus lambda t dt 0 to infinity. And you know the process of integration, I naught e to the power minus lambda t by minus lambda, and putting the integral limit 0 to infinite. Now minus I0 by lambda, and you know upper limit minus lower limit value minus I0 by lambda, that is of minus 1, because e to the power minus infinity means 0. So that is of total charge Q is I0 by lambda. Okay, so is it clear? I hope is it clear. It is clear now. Now moving towards the next question. A charge of Q1 mass M1 is revolving in a circular path of radius r with at center another charge is Q2, that of mass of M2. Find the velocity and the time period of rotation of charge Q1. So the charge Q1 of mass M1, that is mass M1, charge Q1 is revolving in a circular path of radius r, and the at center the Q2 is at rest. Tick. And it is also said in the given question, Q1 or Q2, either of them is negative character. Either of them is negative character. It is given in that question. I forget to write that. So now between these two charges there is Coulomb repulse, a Coulomb attraction. Now according to Coulomb attractions, the force can be written between these two charges, F equals to 1 by 4 pi epsilon naught Q1 Q2 by r square. And due to the rotation of this Q1, a centripetal force is also produced for this rotation, and this value or this force can be written as m1 v square by r. So now for the stable condition, we know these two forces are definitely equal. So equating these two forces, we have m1 v square by r equals to 1 by 4 pi epsilon naught Q1 Q2 by r square. That is, we have the relation in the form of velocity v, this 1 by 4 pi epsilon naught m1 Q1 Q2 by r. Okay, now one question is left again. One question is left, that is of time period. So to find the time period, that is rotation, the time taken by one complete rotation, that of m1 charge of mass m1, that is Q1 charge. So time taken by one complete rotation by Q1 charge is called the time period, and that is of whole path is 2 pi r, that is of circumference of that given circular path is 2 pi r, and the speed of that Q1 charge is v. So 2 pi r by v. So v is putting here, and the value of v is putting here 2 pi r by v, and 2 pi r v is written in this form. Then t comes 2 pi 4 pi epsilon naught m1 r cube divided by Q1 Q2. As r goes inside this of square root, it becomes of r square, and here again r is there, then it comes r square into r, that is of r cube. Okay, this is your time period and this is your velocity expression. Now moving to the next question. Next question. A pith ball having mass m hangs by a fine silk thread of length L in an electric field E. When the ball is given in an electric charge, that is of Q, it stands out d meter from the vertical line. Calculate the electric field in which the ball hangs. Now the question is, before giving the charge, the pith ball is stable here and hangs with the help of the L meter long fine silk thread, and when previously the electric fields also present there, and when the pith ball is given with some charge, that is of Q, and due to the Coulomb interaction or Coulomb force, the pith ball attains a new stable position here, that is, it displaces a perpendicular distance d from its initial position. Now it is also a new stable position in which that if we let the tension of that fine silk thread is T, then T can be divided in two parts. One is T cos and one is T sin in this direction. And due to this gravity, the net downward force is mg, and upward force due to this tension is T cos theta. T tension, where tension T is the tension of the silk thread. Okay, now T cos theta is mg equals to, T cos theta is mg, and T sin theta definitely will have the value of QE because it is a new stable condition. That means T sin theta balances with the Coulomb interaction QE, and T cos theta balances with the downward force due to gravity mg. Now divided by T sin T cos, we have the tan theta is QE by mg and QE by mg, and where we assume theta is much less than, theta is much less than, that means value of the theta is very small. Now we know the value of tan theta, that is of perpendicular distance by of base. So here it is theta, so perpendicular distance, that is of perpendicular distance, then it comes as d, and the base is will be this line according to this triangle, and this line can be written as L square minus of d square because it is a base and the hypotenuse is L and the perpendicular distance is d. So L square minus d square is root, so tan theta can be written as in this form, then E can be written in this form, mgd by q root over 1 by of L square by minus d square. Okay, this is the ultimate result, and also the value of electric field which we have given or which have present in this figure. Okay, now see the problems again. I hope clear. Now moving to the next question. The spatial distribution of the electric field due to two charges AB is shown. Which of the following is correct? 4 options are there and the figure is here. And to solve these questions, we have to know the properties of the flux line, and we know the properties that from positive charges the flux lines are coming out and the flux lines are going towards the negative charges. From these properties we can predict that B is of negative character and A is of positive character, because A, B are two charges. Here you can see the flux lines are going towards that of B charges, and here you can see the flux lines are emerging from that of point charge A. So A is of positive character and B is of negative character. So if you look the options from C, both are positive. It is false because one is positive and one is negative, and both are negative in options D. So it is also false because A is positive and B is negative. So here it is given that both are negative. So option C and option D are false. In option B, A is negative, but we conclude from the properties of the flux lines that A is of positive character, but here it is given A is negative character. So definitely it will again false. It will false. So correct option is A. A is positive and B is negative. But to answer this part of this question, from the first character of the or properties of the flux lines, we can easily solve this question, but due to this part of this option we have to know another properties of flux lines, and it is quite interesting. the property says that the density of flux line is directly proportional to the magnitude of the charge. Again repeat, the density of flux line is directly proportional to the magnitude of the charge. That means where the charge flux lines are very close, that means that the magnitude of the charge is larger than other side, and where the density of flux line is relatively low, then the charge is also there, is the magnitude is low value. So you can see you can see from the figure, the density of flux lines here at point B is smaller than the density of flux lines from charge A. Density of flux line B is smaller than the density of flux lines than the charge A. So by this property we can say the magnitude of charge A is greater than the magnitude of charge point B. So it is also correct. Okay, this is very interesting problem. You can see it again. Now moving towards the next question. HCl molecule is placed in an electric field of field strength is given 3 into 10 to the power 4, that is of Newton per coulomb. The dipole moment of HCl molecule is given 6 into 10 to the power minus 30 coulomb meter, and the maximum torque that can act on that HCl. So we have to find out the torque, maximum torque on that of HCl. We know the general relation of the torque is torque tau equals to PE sin theta, where theta is the angle between the direction of electric field and that of dipole moment. And we know from that property that when theta is 90, the sin 90 will be maximum, that is of one value. So torque tau will be max when theta will be 90. That means when the dipole is placed in an electric field with perpendicular position, then the torque have the maximum value. So putting the value of this electric field and dipole moment, you can find easily the value of maximum torque, that is of 8 into 10 to the power minus 26, that is of P value and E value. Okay, I hope clear. It is very easy onko, easy problem. So moving to the next problem. An electron of mass m of charge q is accelerated from rest in a uniform electric field E, and the velocity acquired by it as it travels a distance L. We know that when a charge q is placed in an electric field E, the force acting on that particle is QE, and due to this force the charge is accelerated and covered a distance L. So according to the Newton's law, when a charge or body of mass m is accelerated with acceleration a, then the force is ma. Now we can easily say these two forces are equal, because of this force is produced by this force. Now acceleration a is QE by m, and we know a relation v square equals to u square plus 2as, with u is the initial velocity. That means the charge here is given in this question, the charge is at rest. That means its initial velocity u is 0. So putting the condition of u 0 and the displacement s equals to L, we have v square is 2 QE by m into L, because the value of a is QE by m, 2 is here, and displacement s is L here. So the velocity is square root of 2qel by m. Okay, I hope it is clear now. Now moving towards the next question. Here it is the next question. A charge q is divided on two objects. The values of the charges on objects show that the force between the objects can be maximum r. That means the question want to say you that a charge q is divided in two parts. That is a charge q is divided in two parts and given it two different bodies, and we have to find these two different parts so that the interaction between two bodies will be maximum interaction. That means the equation of force will be maximum. Okay. In question, in options A, B, C, if you see that total charge of two body is q, that is the if you add 3q by 4 plus q by 4, then the result is q. Here q by 2 plus q by 2 is also q, and 2q by 3 plus q by 3 is also q. That means the total charge conservation is obeyed. Total charge conservation is obeyed. In option D, one charge is q, and second body, the charge of the second body is 0. That is q plus 0 is q. That is the initial charge, that is the conservation of charge is also obeyed. Now if you want to solve this problem, you have to know the trick, and you have to know the how to play with the options, rather solving in a rigorous manner. So I just can show you how to find this answer of this question just by solving the options, or just by playing with the options. So let's start. So from option D, the force can be written. So for option D, the force can be written according to Coulomb's law, q into 0 by some distance. Let this distance is r, so this is 0, because second body charge is 0. So the force between these two body, rather the charges which possesses these two bodies, is 0. The force is 0. From option C, the force F is, here some constant is there and we neglect the constant. Some constant is there. So force q by 2 into q by 2 pi of r square, because some distance is between them, so that is of q square by 4 r square, q square by 4 r square. Option B, the force, let it is 1, it is 2 and it is 3. From option B, the equation of the force, or the value of the force, can be written as, that is of 3q and is q, and it can be written as 3q by 16 and q by 16, that is of 3q square by 16. And from option A, the force F4 can be written as some constant. Here constant is there, but there is no role of this constant, so you can neglect this. So k 2q into q by 9, 3 multiplied by 3, that is of 9, so 2q square by 9. Now from F2, F3 and F4, you can see Now from F2, F3 and F4 you can see easily that the value of F2 is greatest among all. The value of F2 is greatest among all because here the denominator is 16, here the denominator is 9, and here the denominator is 4, and definitely 4 is smaller than other two values. 4 is smaller than other two values, so that means we know the fact that lower the value of denominator is the larger the fraction value. That means 4 is here, that means F2 is largest among all these forces, F1, F3 and F4. So F2 force is largest. That means we can say when total charge Q is divided in the form of Q by 2 and Q by 2, then the interaction, these two bodies which have charges like these have the maximum force rather than these two division. You can say that here no factor is there, but here is 3 factor, here is 2 factor. You can see or you can check by LCM processes. You can find then that F2 is largest among F3 and F4. F2 is largest among F3 and F4. So the correct option is option C. When equal is divided, then the force between that two objects can have maximum value. Okay, let's move on. The dielectric constant of a perfect conductor is, so dielectric constant of the perfect conductor is infinite. You know this value, infinite. Now the best question so far. The charges Q, 2Q, 4Q are uniformly distributed in 3 dielectric solid spheres 1, 2, 3 of radii r by 2, r, 2r respectively. If magnitudes of the electric fields of that is at point P at a distance r from the center of the spheres 1, 2, 3 are E1, E2, E3 respectively, then from the following options which will be correct? It is your question. The question want to say that this is sphere 1, this is sphere 2, this is sphere 3, which have radius of 2r, and it is of radius r, and it is of radius of r by 2. And here is the charge Q, that is of charge 2Q, and that is of charge 4Q. And we want to find the electric field at point P, which at a distance r from each center of the spheres. That is, from sphere 1 the point P is situated at distance r. That is, of sphere 2 the point P is on the circumference, because the radius of this sphere is also r, and for this sphere of radius 2r, the point P lies inside that the sphere, because the distance of P from the center is r. So definitely P have to be lie inside this sphere. Okay. Now for each case we want to find the electric field and also the relation between them, which will be correct answer among these 4 given options. Okay, let's solve. To solve this question, we have to know a equation or relation. That is, when a solid sphere of R we have that of charge Q and a distance R where a point P is taken, then the value of electric field E at R greater than R region, that is outside this sphere, that is of normal relation k q by r square, where k is value of 1 by 4 pi epsilon naught. We know the value of k. So that is, you can say k is a constant. So more focus on these two parts rather on constants. So for r greater than r region, or outside, for the region of outside the sphere, the electric field is given by q by r square relation. But for the point inside the sphere, you have the relation E, electric field k q by r cube into r. For this inside the point, that for the inside point of the sphere. Now for sphere 1, you can see the point P lies outside the sphere. So generally for that case we have to follow this relation. So for sphere 1 we have the relation U1, that is k q by r square, because the charge of that sphere is q, and where we wish to find the electric field is at a distance r from the center. So r is given here. Now for sphere 2, that is of charge 2q, and the point P which is at a r distance, that is of on the circumference of that sphere 2. So it is also given by that relation. So E2 k 2q by r square, where 2 kq by r square, that is kq by r square, is also given by U1. That means we can say E2 is 2U1. Now the complicated case for the inside point. Now point P is inside this sphere 3, because the sphere 3 has the radius of 2r. So sphere point 3, so electric field for the sphere 3, so electric field E3 for sphere 3 is governed by this relation, that is of k q by r cube into r, that is of k, that is the charge of this sphere is 4q, so we have put here the 4q, that is of small r, that is the distance inside the sphere, that is of r, so we put the value of r, and radius of that sphere is 2r, so we put the value 2r whole cube. So after calculation, kq by 2r square is obtained. So this is of can be written again u1 by 2, that is kq by r square is u1, that 2 is divided by u1 by 2. So by these relations, sphere 1, sphere 2, sphere 3, we can easily find that E2 is largest among them. Then comes U1, that is the second large value, and third large value is, that is the smallest value among all. So E2 is greater than U1 is greater than of E3. Okay, so आज का क्लास यहीं पर ख़त्म करेंगे. The end. I hope you have enjoyed this class, and if you have a chance to learn more and more, please like my channel and subscribe. Till then, bye.